Hello and welcome to our talk on Studienstart.de, our web-based pre-course in mathematics for engineering students. My name is David Obermeier. I am working for the Optus project at DHBW Mannheim in Germany, and this talk is joint work with Dr. Miriam Weigel from the CMAT at DHBW Mannheim and Johann Franke, who is also working for the Optus project in Mannheim. The DHBW is the Baden-Württemberg Cooperative State University, which offers a dual system with practical and theory terms. At the location in Mannheim, it offers courses in the faculties of Business and Technology, and at the moment there are approximately 6,300 students enrolled in Mannheim, and we have over 2,000 companies that are training partners. The learning material for our pre-course was developed by the Optus project, which is a joint project funded by the German Federal Ministry of Education and Research, and it's Quality Pact for Teaching. On the bottom right, you can see the universities and institutions that are involved in the Optus project. The online study preparation in mathematics at our university is open for self-registration from June 1st each year, and our pre-course is directed at students in technical degree programs like electrical, mechanical or industrial engineering, mechatronics or computer science. Our pre-course is structured as you can see in this diagram. After registration, students have to do the diagnostic pretest that's covering all subjects of the course. The result then leads to a learning suggestion, helping students to decide which topics to focus on. After the pretest, the students can see the online learning material consisting of learning modules, tests and trainings that can be used for self-study. In addition to this, we offer e-tutored courses and face-to-face courses for students that need more support. In the first week of the semester, there's a mandatory final test for the students of the technical faculty that is comparable to the pretest. The results in the pre- and the post-test are used to evaluate and improve our pre-course. As mentioned, there are 3 ways to use our online learning material. From June on, students can use it for self-study with self-assessment. There is also a forum where students can ask questions and discuss problems. In September, there are also online courses that are supervised by an e-tutor. During these e-tutored courses, students work on one specific subject each week, and every week they get a problem sheet for the current subject that is later corrected by the e-tutor. In addition to that, there are also classic face-to-face courses in September and November that are 1 or 2 weeks long. The basic curriculum of our pre-course consists of these 7 courses. Courses 1 to 6 are a repetition of the secondary school curriculum, and Course 0 is a summary of mathematical basics for students who have problems with mathematical language and symbols, set theory or sets of numbers. There are also 5 advanced courses with subject-specific content that in part deal with topics that are also part of first year's mathematics lecture. Also, these courses are not equally important for all fields of study. The courses Logic and Stochastics are new in 2020. Each of our courses is structured in the same way. There is a small pre-test to figure out in which part of the course's subject the student might have problems. Then there's the learning material that is split into 3 to 5 learning objectives with a training for each learning objective. And at the end there's a randomized post-test to check whether the student has mastered the course's subject now. Our pre-course was developed following the didactical concepts of Bloom, Baumgarten, Meyer and the Conference of Ministers of Education from 2012 and the Minimum Requirements Catalogue in the Mathematics by the Koch Group, which is a German group comparable to the CEFI network. While developing our material, we try to keep the content precise and clear in presentation with many animations, examples and exercises. We also try to offer controlled learning paths by using examples and exercises with detailed feedback on the solution. We now take a brief look at our online material before we move to the evaluation part of this talk. Our pre-course is available to everyone who is interested at our website that you can see on this slide. As you can see, we're not using Moodle but Elias as learning management system. This is the view after the diagnostic entry test. Here are all our courses. If we enter a course now, for example course 4, functions, for which I already did the course's pre-test, we end up at the regular course page. Here we have at the top links to the forum, to a page with special notations for this course and a timetable to help students manage their time. Down here we have the different learning objectives, each with learning module and training. Apparently I have a major problem with rational functions and root functions, so let's enter that learning module. I already worked through parts of the material and the current chapter is on polynomial functions. And here we can, for example, see an animation made with GeoGebra where we can change the degree and coefficients of a polynomial and look at the graph. And down here we have a single choice question on symmetry and zeros of polynomial functions that can be evaluated, and in addition we can expand a detailed solution down here. So after looking at the learning module, let's jump into the training. In the training we have a mixture of standard Elias questions like this single choice question and stack questions like this one where we have to calculate the vertex of a given parabola. At the top of each stack questions one can expand a list with information on the input syntax to avoid input errors. Because we focus a lot on giving constructive feedback, we use stack not only for randomizing variables and plotting, but especially for giving specific feedback on common mistakes and award partial points. So for example, if we swap the x and y value of the correct answer and evaluate, we get the feedback that we indeed swapped the x and y value of the correct answer and our answer gets counted as partially correct instead of just incorrect. We continue with the evaluation of our pre-course program. In 2019 we had 748 first-year students at the technical faculty, 582 of which used our online material in some way. Our online material in 2019 consisted of 11 courses with 35 learning modules and trainings. And stack questions have been added to the trainings of 4 courses, so we have 13 trainings with a mix of stack and standard Elias items such as single choice, multiple choice or closed questions. Here we see the development of the number of participants of the pre-course over the years. As you can see, the percentage of students that take part in our pre-course is pretty stable between about 75 to 80%. Which is a pretty good value in our opinion. Reaching the inactive 20% and motivating them is pretty tough in our experience due to students getting their contracts too late for participating in the pre-course, or some of our training partners not being aware of our mathematics study preparation, or students thinking they just don't need a maths pre-course. In this chart we compare the average results of the pre and the post test of students who did use the online learning material in some kind, corresponding to the green bars, and the average results of the post test of students who did not take part in the pre-course. We can see 2 things here. First, we see that students who used the learning materials did improve their results from the pre to the post test. So students can really improve their maths abilities through the pre-course. Secondly, we see the students who didn't use the pre-course have a much worse post-test result than students who used our material. In part, this can probably also be linked to weaker students getting their contracts later than better students and therefore not being able to participate in the pre-course. The overall increase of points in 2019 was probably because we updated the test in this year and replaced some rather involved questions with more straightforward tasks. Let's look at the effect of tests and trainings on the GAIN score, which is the difference between post and pre-test result. In this chart we look at the risk group of students whose entry test results were below 50%, corresponding to the orange bars, in comparison to students with entry test results above 50%, corresponding to the darker green bars. From this we see that all students, and especially students of the risk group, benefit greatly from performing tests, and that all students are able to increase their post-test results even more if they perform more tests and trainings. So as expected, formative assessment has to play a major role in study preparation. We also did a survey on the whole pre-course and online material that was filled in by approximately 20% of the students participating in the pre-course, and that gave us an overall positive feedback. So lessons we learned from that and the last years of pre-courses are that students get along very well with the online material and like the online tests and trainings. Especially they like the combination of different question types and the immediate detailed feedback. Also, we learned that students don't use the forum much, but prefer to write emails. Furthermore, we learned that students often have problems managing their timetable and that the motivation of the students decreases over the time. So these problems can often be solved by having e-tutored courses. And finally, we learned that the gain score increases with the amount of testing. That was our talk on our pre-course at the Cooperative State University in Mannheim. Thanks a lot for your interest, and now please feel free to pose your questions.